Alright, this is Unit 8, the review, second part for Algebra 2. Write the function with the following roots. So, imaginary and irrational roots come in conjugate pairs. So, this would be a positive or a negative 6. This would be negative 3 plus or minus root 5. That means we really have 4 roots. If we were to multiply out our equation at the end, we would get an x to the 4th equation. But since it did not say standard form, we are not multiplying this out. Alright, so that means my roots would have been equal to x at the end. I need to get these equations equal to 0. We never see functions with radicals in them, so I need to get rid of the radicals. Once the radicals are isolated, we're going to square both sides. So I get x squared equals, off to the side, square root of 6 times the square root of 6. Okay, if you haven't figured it out by now, when you have a radical times itself, you just get the number itself, because 6 times 6 is 36, and square root of 36 is 6. So you can just shortcut it and realize that you get a 6 here. Set it equal to 0 by subtracting, so x squared minus 6 is equal to 0. This one's ready to go. The one on the right, just like with the imaginary numbers, you want to get the radical by itself before you square both sides. It's easier. So we're going to add that 3 over with the x. And now we're going to square both sides. So x plus 3, I'm going to have to double distribute. I write it out twice. Square root of 5 times another square root of 5 is just 5. Double distribute. Combine terms. Subtract your 5. And now this piece is ready, so our function was the x squared minus 6 in parentheses, the x squared plus 6x plus 4 in parentheses. Number 12, divide using long division. So they're coming out and telling me I have to use long division, so I have no choice. I do realize that not all of my terms are there, so I'm going to put in a 0 term for the x, and I'm dividing by x plus 3. So what do I need to multiply x by to get a 2x cubed? I need a 2x squared. Distribute 2x cubed plus 6x squared. Subtraction means change both signs. 2x cubes cancel. We get negative 2x squared. Bring down the next term. Start it all over again. Oops, got rid of too much. Undo that. Okay. What do I multiply x by to get a negative 2x squared? I multiply it by negative 2x. So when I distribute my negative 2x, I get negative 2x squared minus 6x. Subtraction step, change both the signs. 2x squareds cancel, so I get 6x, bring down the minus 5. And what do I multiply x by to get a 6x? I multiply it by a 6. Distribute your 6, you get 6x plus 18. Subtraction step, change both the signs, and we get negative 23. So final answer is 2x squared minus 2x plus 6 plus a negative 23 over x plus 3. Okay, h of k is that function. J of k is that function. Find h of k over j of k. Well, that's a symbol for divide the two.
Hello. Hello.
Okay, so negative 5x squared. Oops, helps if we put them in order first. How about x cubed minus 5x squared plus 8x plus 4? And we're going to divide it by, that should be an x, not a k. My apologies. X minus 1. Alright, so what do we have to multiply x by to get an x cubed? We need to multiply it by x squared technical difficulties. So x squared distributed gives us x cubed minus 1x squared. Subtraction step, change the signs, those cancel. I get negative 4x squared, bring down the 8x, do it all over again. What do I multiply the x by to get a negative 4x squared? I multiply it by negative 4x, and that will give me negative 4x squared, positive 4x when I distribute. Subtraction step, change both the signs. 4x squareds cancel, and I get 4x, bring down the 4. What do I multiply x by to make a 4x? Multiply by a positive 4. So I get 4x minus 4 when I distribute. Subtraction step, change both the signs. 4x's cancel, and I'm left with 8. So final answer is x squared minus 4x plus 4 plus 8 over x minus 1. Alright, number 14. Is x plus 2 a factor of that? Well, you can try to factor that. You can do long division, or you can do the remainder theorem. The remainder theorem says take what you hypothesize your root to be. So if x plus 2 is a factor and we set it equal to 0, that means we're hypothesizing that the root is negative 2. And if I plug that negative 2 into that polynomial, it should come out to be a 0 if it in fact is a root. We get 4 plus 8 plus 12, so we're coming out with 24. Since I did not get a 0 here, then negative 2 is not a root, which means x plus 2 is not a factor. So no, explain, because when you plug in negative 2, you do not get a 0. Okay, factor this, given that negative 3 is a root. Alright, I believe this might have been in that extra day that we skipped saying it was a bonus. We can figure this out. So if negative 3 is a root, then that means x equals negative 3. They want us to factor it. Factoring is breaking it into pieces that multiply together to get that for an answer. Well, you get your roots from your factors. So if I manipulate this equation so that it equals 0, then that means that the x plus 3 was in parentheses, making the x plus 3 one of the factors of that equation. If I want to find the other factor, all I needed to do is divide. So, like 5 times something makes 10. The 5 and the something are the factors of 10. How do you fill in the blank when you can't do it in your head? 10 divided by 5 is 2. So if you take the answer and divide it by one of the numbers that multiplies, you find the other one. So that's what we need to do with this polynomial, is we're going to do some long division. 2x cubed plus 11x squared plus 18x plus 9. We're going to divide it by x plus 3, which is the factor. That's what would have been in parentheses before we set it equal to 0, and see what we get. Now, if x plus 3 is a factor, then when we divide, it should hopefully come out even. Alright, so what do I multiply to x to get a 2x cubed? I multiply a 2x squared. So that's 2x cubed plus 6x squared. Change your signs for the subtraction piece. 5x squared plus 18x. Excuse me. What do I multiply to x to get 5x squared? I multiply a 5x. So 5x squared plus 15x. Change the signs. That gives us 3x plus 9. I have to multiply the x by 3 to get my 3x. and when I change my signs for the subtraction step, everything cancels out and it goes in evenly, which it should have if it's going to be factoring. So one of the factors is x plus 3. The other factor is 2x squared plus 5x plus 3. And they told us to factor it, so we need to provide both factors. Okay? Now, there is a little hiccup here. The other factor I got is a quadratic, and I really do need to check to see if I can't factor it farther. So if I do factor by grouping, 2 times 3 makes 5. Sorry, 2 times 3 makes 6. The 2 plus 3 makes the 5 in the middle. Therefore, I can factor this more. So 2x squared plus 2x plus 3x plus 3, groups of 2, I'm going to pull out 2x, x plus 1, I'm going to pull out a 3, x plus 1. So what I got when I divided can be factored farther into 2x plus 3 and x plus 1. And then don't forget to bring down the original x plus 3. And now our problem is factored. This is not a common occurrence on the Regents. I want to say I've seen it shown up once, maybe twice, but not extremely common to ask this kind of question. Okay, but it has been there. All right, so if x minus 2 is a factor of a function, what's the root? Well, we always take the factors and set them equal to 0 when we do it from the start. They're all the way down to the next to last step. So take that x minus 2, set it equal to 0. That makes the root 2. What is the remainder when you take that polynomial and divide it by x minus 3? You can do long division, but seeing how you got the 10th for exponent, that's an awful lot of dividing. So this is where you want to remember the remainder theorem. If they're going to come right out and ask you for remainder theorem is the way to go. So the remainder theorem says take your hypothesized root, so that means take your factor, set it equal to 0, and take your root that you think you might have and plug it in. So 3 to the 10th minus 3 times 3 to the 8th plus 5 times 3, and see what you get. 3 to the 10th minus 3 times 3 to the 8th plus 5 times 3, and I messed up again because of this calculator. Hang on, messed up again. Holy cow. I don't like this calculator that I have to use, guys. Just saying. Alright. Still not sure I like what I'm getting. Alright, 3 to the 10th. Minus 3 times 3 to the 8th. Plus 15. Well, I'm getting 39,381. Seemed it a little high to me. Yeah, okay. So, there's our remainder. Kind of weird. Alright, if x plus 1 is a factor, so we know it's a factor, find the value of k. Well, if x plus 1 is a factor, when we set it equal to 0, that means negative 1 is the root. If I know that it's a root, which I do, because they said it was a factor, When I plug it into the polynomial, I must get a 0 for an answer because all roots have a y value of 0. So I'm going to plug my -1 in everywhere I have an x, set it equal to 0, and solve for k. Alright, so this is going to give us -2 plus 7 minus a k minus 3 equals 0. Combine like terms. That's going to give us 2 minus k equals 0. When I add k to the other side, k is going to equal 2. Alright, and the last problem. Is x plus 4 a factor of this? Well, if x plus 4 is a factor, then x equals -4 would be the root. So by the remainder theorem, if I just plug that -4 in, I need to get an answer of 0. If I get an answer of 0, it's a root. Alright, let's see if I can do this in my calculator. 4 times -4 to the 5th minus 3 times -4 to the 2nd I'm getting -4,153. No, because when plug in -4, do not get 0.